Welcome to Space for Women show. Today we have the privilege to serve as closing the World Space Week 2020, which theme is Satellites Improve Life. We are sharing space engineering theme today, series 24, the importance of systems engineering and human systems integration, methodological ways of systems thinking.
Sí, gracias por estar en el show de hoy, cerrando la Semana Mundial del Espacio. Nuestro show de hoy se va a llamar Ingeniería Espacial, la importancia de la ingeniería de sistemas y la integración de sistemas humanos.
We will be discussing following questions. What are some of the human operator design constraints for crewed space flights?
Una de las preguntas que vamos a responder es, ¿cuáles son algunas de las limitaciones del diseño de operador humano para vuelos espaciales tripulados?
How are interfaces human-machine designed to be inclusive?
¿Cómo se diseñan las interfaces hombre y máquina para que sean inclusivas?
What do you see missing in our current engineering educational curriculums for next generation engineers to be ready to tackle new interplanetary missions, challenges, and tech concepts?
Y por último, ¿qué ven que falta en nuestros planes de estudios educativos de ingeniería para que los ingenieros de las próximas generaciones estén listos para abordar los desafíos de las misiones interplanetarias y los conceptos tecnológicos?
Welcome to our guests of honor, Mr. George Salazar. He's a NASA systems engineer, and Christine Nolan, the founder of Hubble Financial, and our official UNOSA Space for Women mentor, Mrs. Natalia Lemarcos. She's an aerospace engineer, and our moderator for today will be Bianca Cefalo, and our co-moderator will be Swati Shanta.
Nuestro equipo de hoy será conformado por George Salazar, que es ingeniero de sistemas de la NASA, Christine Nolan, que es la fundadora de Hubble Financial, y las mentoras Natalia Lemarquis y moderadoras Bianca Cefalo y Swati Chandra.
The floor is yours, Bianca.
So thank you. Good morning, afternoon, evening, everybody. Thank you for being with us today for the closure of the World Space Week. And for today, as Ian has said, we're having a full themed engineering event, which I'm extremely happy to moderate, being myself an aerospace engineer and sharing the floor with so many amazing engineers today. So as we said, we will have three main questions, three main topics that we want to address today. And I will start with George Salazar, but before I will give Laura the chance to translate.
Estamos muy contentos de estar cerrando la Semana del Espacio con este evento, sobre todo porque nuestra moderadora también es ingeniera aeroespacial. Y primero le vamos a dar la palabra a George Salazar, que va a empezar con esta introducción.
Thank you, Laura. George, the floor is all yours. I know that you have slides that you want to share with us.
All right, excellent. So thank you for inviting me to be a speaker here. I'm very passionate about these subjects, systems engineering as well as human systems integration.
Okay,
but also
we have network issues here. Can you hear me? You can hear me, George?
Yeah, it's all good.
We lost connection with George.
Okay.
We can hear George.
No, I can hear George and I can hear everybody.
It's all good.
Okay, so my hope is just to give you a short presentation in the next 10 minutes about the challenges that NASA has going to back to the moon and onto Mars eventually, but also what it's going to take in terms of methods and tools. And that's where systems engineering and human systems integration comes into play. So Laura, I'll let you translate.
Thank you.
Can't hear anyone right now.
Hoy, por estos próximos 10 minutos, vamos a hablar de la importancia de la ingeniería de sistemas.
Can we just continue?
Can everybody hear me?
I can hear you. I think it's
we can hear everybody here. Everything is going okay.
We continue then.
Entonces, la charla de hoy es de los retos que han tenido en las misiones a la Luna y en las misiones a Marte para la importancia de la ingeniería de sistemas y la integración humana en estos casos. Go ahead. I'm sorry.
All right, so there's challenges ahead. So let me just say a few words about challenges ahead, and it's going to be both for the human and as well as the systems. But let me just say a few words about how we
stop the stream.
How we operate and
solve this technical issue now. George,
sorry, George. Apparently, there is a technical issue with Ian.
Okay, so the current situation we have in operations in space is we have a station operating and we have different support groups that support space station right now. Over 200 mission control in Houston as well as Russia. I'll let Laura translate.
En este momento, el reto más grande es que existe una estación internacional del espacio y existen muchos sistemas operándola. Hay sistemas en Houston, con la Mission Control, el control de misión, y hay sistemas en Rusia.
In the future, we're talking about going back to the moon and eventually Mars. But we're going to have a little bit of support with NASA at the Johnson Space Center. However, because of the long communication delay, we cannot depend on mission control for critical events. We're going to have to depend on onboard mission control, which is basically artificial intelligence. So we are going from what is now crew mission control dependent operations to the future, which is crew vehicle dependent operations. And I'll let Laura translate.
En este momento, las misiones que han habido hacia la Luna tienen controles desde Houston, desde el control de misión. Para los vuelos futuros a la Luna y especialmente para los vuelos a Marte, las comunicaciones van a estar muy lejos y no van a poder comunicarse desde la Tierra. Entonces estamos hablando de las comunicaciones, del control de la misión desde el espacio, lo que significaría controlar esas misiones de humanos por medio de inteligencia artificial.
So let's talk quickly about human and technology needs. So the human obviously needs water, needs oxygen to breathe, needs food, and more importantly, we are social animals, and the isolation is going to be a challenge as well. I'll let Laura translate that.
Los humanos necesitamos espacio, necesitamos comida, necesitamos líquidos, y un reto también muy importante es que necesitamos socializarnos y el aislamiento en una nave va a ser un problema y un reto que tenemos que enfrentar.
So the technology challenges is things like habitats, okay? These are going to be the ones that need to support the astronauts for a long period of time. But the problem is trying to land something that huge is totally new for NASA. And so we have to find better ways of landing huge space structures on another planet. The other challenge is electricity. All this is going to require electricity. So we have to find better ways of electricity. One possibility is nuclear energy. And then taking the soil and converting it to water for usage as well as growing plants is going to be a challenge too as well. And of course, technology is, as far as computers is concerned, we need computers for everything. But the big challenge is the radiation effects on electronics. And so we have to find better ways of developing electronics for deep space missions. Laura?
George, excuse me for a second. Are you going through the slides? Because I don't know if it's just me, but I only see the first slides of your deck.
Yeah, I only see the first slide.
Yes, myself as well.
Wow.
Just the first.
Yeah, okay. So if you were going through the slides, we've missed them.
All right, step by, let me reload then.
Now I can see.
All right,
yeah,
can you see?
So good now.
Okay. All right, so I was up to this point right here. And the last slide shows electronics, and that's the radiation effects of electronics is one of the challenges. And Laura, do I need to repeat, or are you okay?
I think I'm okay, but I may need, you said first the challenge was the habitat, then landing, then electricity, and then technology. Was that it?
After electricity.
Now I can't hear you anymore.
Is converting it to water and then electricity.
Okay, I think okay, los retos principales, pido disculpas porque pasó un tiempo, los retos principales que tienen en este momento para estas misiones son primeramente el hábitat, el tamaño de un hábitat que soporte la vida humana, la electricidad, sostener electricidad hasta ese punto puede requerir hasta energía nuclear, ¿cierto? Producir líquidos tan lejos y todos los retos, la tecnología que se requiere para sostener la vida humana en otro planeta.
Okay, so in order to accomplish these goals, we're going to need more and more systems engineering, which involves a lot of system thinking. So systems engineering is a process to methodically develop systems, especially for us spacecraft systems. So what you're seeing on the left-hand side is the definition and the composition of a system, and defining what that
George,
system.
Excuse me again, but it looks like the slides are not moving.
They're not moving.
We are on the human and technology needs now.
Okay, let me stop sharing and synchronize. So I will try to make up time and shorten some of my presentation. So what you're seeing here is a chart that represents two aspects. One is the systems engineering, systems thinking aspect. So the upper portion of the chart shows the systems engineering process. So it's called the V diagram. The left side of the V is basically the definition and decomposition of the system. The right side is the integration and verification and validation of the system. Laura?
Entonces, este diagrama se llama el diagrama V. Y el lado izquierdo del diagrama, what was the left side? I'm sorry. I want to say it correctly. The integration?
Integration.
El lado izquierdo demuestra la integración de los sistemas de la ingeniería y el lado derecho, in the right side.
Integration, verification, and validation.
Okay, y el lado derecho es la verificación y validación. Okay, sorry.
Okay, next click, please. So what you're seeing here is how systems thinking comes into play. So system thinking is a way of understanding how systems operate. So you're seeing the interconnection of system components. You're seeing the system behavior. When you bring components together, there's a certain system behavior that is that comes and emerges out of that interconnection, and the system feedback as these components connect and communicate with each other. And that's part of systems engineering. Next click, please. So in essence, what we're trying to do, another click, is to basically maximize understanding what the requirements are, minimizing the costs as much as possible, and more importantly, reducing the risk. Laura.
Ok, entonces en este diagrama se demuestra cómo se conectan estos sistemas. Está el comportamiento del sistema, la retroalimentación del sistema y su interconexión. Estos, viéndolos juntos, simplemente significan que tenemos que reducir el riesgo y reducir los costos, pero más que todo reducir el riesgo de estas misiones.
Okay, next slide, please. So click, please. So let me just say one thing. The traditional view of systems has always been the hardware and software, and that's the way I was trained as an engineer. And one click, please. These systems are basically deterministic. You can determine what and how that system is going to operate. Laura?
Los sistemas tradicionales son el de hardware y software. Y por medio de la interconexión se puede determinar cómo se van a comportar estos sistemas.
Okay, next click, please. But in reality, it's not just the hardware and software, but it's also the human, as far as the human systems integration view of a system. Click, please. The thing is that humans are non-deterministic, interfacing with a deterministic system, and that's our challenge. Next click, please. So the human systems integration effort involves six, at least at NASA, 6 domains: training, operations, habitability, safety, maintenance, and supportability. But the key factor is human factors engineering. Next click, please. But there's an interaction going on here where we have 2 areas of integration. One is requirements, and the other one is trading between the requirements to optimize the system. Laura.
Okay. Entonces, en el sistema de la integración del diseño humano, no se considera solamente el hardware y el software, sino también el ser humano. El ser humano no es predecible, no está, sus reacciones no están predeterminadas. Entonces, al integrar el ser humano, NASA tiene 6 factores que se integran para manejar el sistema. Estos son los 6 factores: habilidad, habitabilidad y ambiente, entrenamiento, operaciones, ingeniería de factor humano, seguridad y mantenimiento y apoyo.
Next question, next chart, please. All right, so the total system, human, hardware, software, the environment, optimization happens in an integrated fashion and not components that have been independently optimized. Click, please. So the left-hand side of this diagram shows human systems integration interacting with systems engineering, ensuring that the human element is involved in all development aspects of system development. Next click, please. And finally, the human-centered design is key to ensuring that the human element is included in the system. A hardware and software system by itself is not optimized until the human, the hardware, and the software is optimized. We're trying to maximize system performance. We're trying to minimize cost. And we're trying to, again, minimize risk. Laura.
La integración total del humano, el hardware, el software y el medio ambiente solamente puede pasar de forma integrada. Esa forma integrada se da o se resulta en reducción de costos, optimización de los recursos y una reducción significativa del riesgo.
Next slide, please. And I think that concludes my presentation. Thank you.
Thank you very much, George. And but especially thank you for going through both you and Laura with some technical difficulties. It was a great presentation. So because we have a second half of the show that is all based on Q&A, so we are going now to share Kristine's story on system engineering. Kristine, the floor is all yours.
Okay, well, thank you so much, George, for all of that very useful information. And it's so funny to hear what you've said, because there's a lot that aligns with some of the information I'm sharing as well. So first, I'll give you a basic overview as to what I do. I am an innovator and entrepreneur. I started a company called Hubble Financial, and it's an information technology company that provides business intelligence, primarily right now in financial services, by adopting systems engineering from a data-centric perspective. So what do I mean by that? Ultimately, what we're using is the construct of systems engineering as a whole to propel and serve as our primary function for driving our data and creating our results. So NASA refers to systems engineering, its technical definition, as the art and science of developing an operable system capable of meeting requirements within often opposed constraints as a methodical, multidisciplinary approach for design, realization, technical management, operations, and retirement of a system. And so I've been using this approach in my work with my company on the back end. And I've basically just broken this down into 5 different components: the system, models, the data sets, the information, and the knowledge at a higher level. I don't know if I have time.
Do you want to pause for Laura to translate?
Yes, I'm so sorry, Laura. I apologize. Please.
Okay. Everything you're saying is very interesting, so I was just listening.
I am so sorry. Do you want me to take it back to Hubble Financial? Maybe you can just translate the definition.
I'm just gonna do like a short version of what you said, if you don't mind.
Perfect. Perfect.
Okay. All right. If you can move the next slide so I can sort of translate as I go. I'm sorry.
Yes.
Okay. Christine Nolan es una innovadora y es la CEO de Hubble Financial, que es una compañía que se dedica a los servicios financieros desde la inteligencia artificial. Christine, can I see that slide?
Right. Yes, I'm so sorry. I was just trying to zoom.
Ella define, y NASA define la ingeniería de sistemas como el arte y la ciencia de desarrollar sistemas operativos capaces de conocer o medir los requerimientos con a menudo límites como un aborde multidisciplinario al diseño, realización del manejo de tecnologías, operaciones y el retiro del sistema. Okay.
Amazing. Thank you so much. So ultimately, Hubble, the primary methodology, as I stated, is it's using systems engineering to provide our intelligence tools to businesses and currently financial professionals. And we are doing this by sales prospecting, providing research, and expanding sales distribution for financial advisors, insurance producers, consultants, banks, financial institutions as well. Laura?
Hubble Financial, como su metodología, utiliza los datos de acceso abierto integrados y se los realiza en forma de inteligencia artificial para venderlos a negocios y a profesionales financieros, ya sea para predecir el comportamiento del mercado, para poder vender un producto mejor, etc.
And I was so excited to see that George also included the systems engineering V model, which is such an incredible model because I really feel it's the basis to problem solving at a fundamental for so many things. And when you break this down into the 4 basic components, measuring effectiveness, measuring performance, allocating functions on performance, and then device function and performance, I've really used that as I've used that as the model for our foundation. And so here I more intricately explain how those items are used with our data analytics tools. But I won't get into too much detail because I know we have a lot to get through. So how did I get to working at NASA and working in data science from Broadway? I'll give you a bit about my background. I don't have a typical engineering track. I have a Bachelor of Fine Arts in Music and Theater, which is ultimately a hybrid degree of the fine arts. So I studied music composition, singing, acting, dancing, art, and I always had a very strong interest in aerospace engineering and design, and working in the space science industry was just a dream of mine. So I did a course at MIT in the Introduction to Aerospace Engineering and Design, and that confirmed my passion. And I knew that this is what I had to do it. I just had to. And I'm currently working on my master's in data science and systems engineering that is in process. My work experience includes working on Broadway, film, television. That was nationwide tour through Canada. And then I worked at the President's Committee developing research and designing state educational policy reports for the First Lady's STEAM educational initiative. And that was ultimately using the arts as a tool to incorporate the arts into STEM curricula in education across the country at different schools, and primarily schools that were underdeveloped or in areas that were of lower income. And from there, I worked at the NASA's Goddard Space Flight Center for the James Webb Space Telescope mission. And then I began assisting in the Integrative Design Lab for the LUVAR mission in their 3D print work. And from that, I just randomly won this Tech Innovation Award. And so I said, okay, maybe I'm on the right track with technology and innovation. How can I explore this? How can I use what I've learned in engineering working at NASA to novel something, to create something of my own that will make impact? Oh, I'm so sorry, Laura.
No, I was super interested. Can I get back to the slide with your resume? Yeah. Okay. So Christine Nolan tiene una historia muy diversa que nos estaba contando. Ella viene de Broadway, del teatro musical, y en eso trabajó mucho tiempo, pero siempre le interesó la ingeniería aeroespacial. Entonces, después de estar en Broadway, después de aparecer en televisión, empezó a estudiar ingeniería aeroespacial, trabajó en la NASA. En este momento está haciendo su máster en ingeniería aeroespacial y también, después de adquirir todos esos conocimientos, decidió emprender y crear Hubble Financial, que es su compañía en la que ella ha incorporado los conocimientos que adquirió tanto en su vida profesional inicial como trabajando en la NASA, como en lo que está haciendo ahora. Okay.
Beautiful. Okay. Thank you. So I started working for the James Webb Space Telescope mission. And for those of you who are not familiar with it, I'm sure George knows a ton about it, has probably worked on it even. But the James Webb Space Telescope is the largest, most expensive mission to date. It's a $10 billion project. It will be launched in 2021. In October 31st is the estimated launch date, knock on wood. There have been some delays, but there's been a lot of progress. They just completed their last 2 testings at Northrop Grumman in California. So these spacecraft will be now put on a barge and sent across the Atlantic to French Guiana. for its launch. And this is all in partnership with ESA, the European Space Agency, the Canadian Space Agency, and NASA. So I'm just going to give you a little bit of an overview about the engineering concepts behind James Webb Space Telescope because it's fascinating. So the James Webb Space Telescope is ginormous. It's about the size of a football field, and it has to fold up very, very tiny, like origami, into the very tip of a rocket, as you can see right here. Laura?
Sí, ella nos estaba diciendo que el proyecto en el que ella está trabajando en este momento es el telescopio más grande, el telescopio James Webb, que se va a enviar al espacio el 31 de octubre de 2021, está previsto para esto, desde Guyana Francesa, y este es un proyecto colaborativo entre NASA, la Agencia Espacial Europea y la Agencia Espacial Canadiense.
Thank you. So James Webb Space Telescope will orbit the sun. It'll be located at Lagrange Point 2, which is about 1.5 kilometers from Earth, which is deep, deep space. So we cannot use humans to do any maintenance the way we were able to do with the Hubble Space Telescope. And because of that, risk is higher. And it's a riskier project, and it's a higher investment as well. So this gives you an understanding as to where the telescope will be in approximation to the sun. As you can see, the bottom of the spacecraft is facing the sun, and that's why there's this silver shield, also known as the sun shield, that will protect the components of the primary mirror and the structure itself from overheating so that the infrared can work appropriately. And this gives you a bit more, a deeper look at the components. Here, as I said, there's the primary mirror, which is those beautiful gold hexagon segments. The secondary mirror, the spacecraft bus, which processes all of the data and sends it back to us on Earth at the Science Institute here in Baltimore, and then the sun shield as well. And as I said, on one side of the spacecraft, it's very, very hot, and that's why we have this protective layer. And on the other side, it's extremely cold in space. It gets as cold as 40 Kelvin. So obviously, just so many components go into making the structure live in such an extreme environment.
Christine, can I translate so far so I don't get lost? All right. Can I see the slide before that? Sorry, that one. Okay. No, the next one. Okay. So este telescopio que estamos, el telescopio James Webb, es un telescopio que va a estar muy cerca al Sol. Entonces, por eso, if you can put the next slide, the one that shows the telescope, the next one, the one that has a big picture. Este telescopio, como ustedes se pueden dar cuenta, por un lado está muy cerca al Sol. Entonces necesita un bloqueo, una parte que bloquee el Sol, ¿cierto? Y esta es la parte que dice acá Solar Shield. Detrás es muy frío y es donde están todos los componentes que le van a estar enviando información a la Tierra. Okay.
Beautiful. This gives you an idea as to the size of the James Webb Space Telescope. Here on the left, you can see that Hubble's was 2.4 meters in diameter, Spitzer about 0.8 meters, and then Webb, which is 6.5 meters. This is obviously the largest telescope we will ever send into space. Here gives you, at the bottom of the page, a deeper look at the wavelength coverage. So Hubble primarily was in a visual spectrum, and the James Webb Space Telescope is exciting because it will be in infrared, which will allow us to see basically behind large dust clouds, so we can explore potential exoplanets and environments on exoplanets, which ultimately we're hoping will help us determine if there are, the fundamentals of building blocks of life on other planets.
Ok, entonces este telescopio no solo es más grande que los otros telescopios que se han enviado, pero también tiene la capacidad de ver por ondas infrarrojas. Esto nos va a permitir ver detrás de muchos cuerpos celestiales, procesar mucho más información y en últimas lo que nos puede permitir es tratar de encontrar la respuesta de si hay vida en otros planetas.
Here's a basic overview regarding the design components. Webb has 18 hexagon near segments, and they're actually covered in real gold, which is because gold is the most reflective property. And I think that's really fascinating. It's only about a golf ball's worth of gold, but behind that film is made of beryllium. Each plate is made of beryllium, which is a really light substance, but also very, very strong. And this also gives you an idea as to how much larger it is than Hubble. Once again, this is the overall structure, which will provide you with the background of the main components that make up the James Webb Space Telescope. If you can see here, the gold hexagon segments is where the light reflects off of. And from there, the light reflects to the secondary mirror, which then reflects back into this, which looks sort of like a black nose, the tertiary mirror. And all of that information is processed in the spacecraft bus, which is then sent back to us here on Earth. So that's the general pattern of the light reflection.
Ok, entonces el diseño de este telescopio, las partes hexagonales que están cubiertas en oro son el espejo principal. La luz se refleja en el espejo principal y ese reflejo va al espejo secundario, el cual le refleja la información a esta parte del centro que va guardando la información y se le envía al bus de abajo que se le envía a la Tierra.
So as I said, the James Webb Space Telescope sun shield is really, really cool. It's basically made of 5 different layers of something called kapton, which is really this tiny, very, very thin film. It kind of feels almost like a mylar balloon. And you'd be surprised how that material can block out that much heat and light from the sun in order to protect the spacecraft. And that is made by Northrop Grumman. And it folds very, very, very intricately. And then once it's in space, the deployment, during its deployment, it unravels really elegantly, almost like origami.
Este parasol se dobla cuando se envía al espacio, está doblado y cuando ya está situado donde necesita estar, se despliega como un origami.
So when I started working for the James Webb Space Telescope mission, I started working in their 3D printing, and I basically launched their 3D printing initiative for their telescope and worked with an engineer to design all of those. And that's what allowed me access to the integrated design lab. And that's where I got to learn ultimately what systems engineering is from start to finish, the birth, the inception of the idea, assessing the risks, and walking through that process step by step. So really seeing a dream become a reality. And that was what got me excited about engineering in the first place, because it actualizes a fantasy. Ultimately, it's something that's not tangible. And the idea of seeing all those engineers work together and problem solve together and make something a reality was what made me really passionate to work in this industry. So The LUVOIR is ultimately the successor to the James Webb Space Telescope mission. Its proposed launch is potentially in 2030s at some time. And that will be using the, I believe it's the visual spectrum, ultraviolet, and partial infrared spectrum as well, whereas James Webb Space Telescope is only infrared and a tiny bit of visual, and Hubble is all visual, the visual spectrum. Would you like to?
Yes, I just have a question. You said that the LUVOIR is going to have infrared and?
It's semi-infrared, ultraviolet, and some visual spectrum.
Okay.
Yeah.
Entonces, este telescopio, el LUVOIR, es una generación más avanzada que el James Webb, y este se va a lanzar en el 2030. Aparte de tener visión infrarroja, como tiene el James Webb, también va a tener visión ultravioleta y va a tener visión visual normal como el Hubble.
So this sort of brings me, this idea of 3D printing brings me to the technology movement of the 1960s and how I believe my journey working in the arts and more as a creative, how has that allowed me to have a more unique approach or to problem solve a little bit differently than say many of the other standard engineers at NASA who had a more typical trajectory. So the technology movement, if anyone is watching is an engineer, I'm sure you'd be excited to learn about this, but this movement ultimately looks at the engineers, the scientists, and the creative cultures that all began to merge in the 1960s. And this was right during the Apollo mission. So it was a very, very exciting, innovative time for technology, space science, and the arts.
Tenemos que empezar a mirar este movimiento en tecnología porque nuestra presentadora, como ustedes ya lo saben, pasó de las artes al mundo de la tecnología y el espacio. En los 60 se dio el movimiento más grande de tecnología que se llevó también acarreado por las misiones de Apolo y por todos los cambios tecnológicos de los años 60.
The 1960s was an era of great technical change. So we saw this clashing of exuberant technical enthusiasm where everyone was very excited, but at the same time, there was fear about the power and growth of technology and how that would affect people and loss of jobs. And so looming over all of this was this man, C.P. Snow, and in 1959, he wrote a critique which basically talked about the divide between the humanities and science. And he called this the two cultures.
En los años 60 había mucha emoción por las nuevas tecnologías, pero también había mucho miedo por las cosas que eran desconocidas. Entonces C.P. Snow escribió un libro que se llamó Las dos culturas y la revolución científica, en el cual él hablaba de dos culturas separadas.
And his response to this divide between the arts and the sciences was to create a third culture, which would ultimately merge the two.
Su respuesta era no tener dos culturas separadas, sino una tercera cultura que incorporara la tecnología con el arte y la ciencia.
So there are many examples through the 20th century that we can look at, but I'm going to spend a few moments just talking about arts and technology movement of the 1960s. So this was right when NASA Art Space was founded. And this era was really different because here we're seeing for the first time humanitarians, artists, political activists, engineers who are all working together and receiving public funding to collaborate and to build projects. And this is actually one of my favorite paintings. This is called Grissom and Young by Norman Rockwell. It was done in 1965. and it's done at the astronauts John Young and Gus Grissom, and they're getting suited up for the Gemini program. And NASA actually loaned Norman Rockwell the spacesuits so he could so intricately paint the spacesuits and get all of the engineering concepts and design concepts accurately in his painting. But this was all funded by NASA. This was 1965.
En 1965, la foto que acabamos de ver la pintó Norman Rockwell y fue comisionado por NASA para hacer este cuadro. De hecho, incluso le prestaron un traje de astronauta para que el señor Rockwell pudiera ver todos los detalles y pudiera crear ese cuadro financiado totalmente por NASA.
And a second key frame that was occurring during that time is engineers were starting to emerge as their own professional community, separate from scientists in the 1960s. The National Academy of Engineering was officially formed in 1964, and there were calls for a more humanized form of engineering and calls to revamp education for the next generation of engineers to create more innovative solutions and to have more creative ways to problem solve.
Entonces, en los 60 se empezó a separar. Yes.
Can you hear me? Yeah. So we are running a bit out of time because Natalia also has to share slides. So when you're done with the translation, Christine, if I can ask you to wrap the presentation, otherwise we will not have time for Natalian questions.
Got it. Can I finish in 2 minutes? Does that work?
Yeah,
or do I need to
and then we give Laura time to translate all the remaining of your talk.
Okay, got it. So to wrap this up fairly quickly, so ultimately the 1960s was an enormous time of change. Norman Rockwell was on the cover of Time magazine, and the arts and engineering were being made official. This is one of my favorite pictures because this is Robert Rauschenberg and Billy Kluver, and you can't tell which is the artist and which is the engineer at this time. And so there were a lot of organizations and foundations that were making arts and engineering official, and there's a tremendous amount of funding behind these. The art and science of recognizing original ideas. This is a quick overview as to how you can, right now we're using things like design thinking to have a more creative approach to our problem solving. Instead of just a linear methodology, we're starting to use the other side of our brain, and this is allowing us to have more innovative concepts, to introduce more innovative concepts. And an example of this is actually using the art of origami. The folding of the James Webb Space Telescope itself is an art form, and using that component in the engineering design of the James Webb Space Telescope. I'll just touch on Leonardo da Vinci. He was effectively everyone refers to him as an artist, but he was an engineer ultimately. And these are some actual drawings he did of the first flying machine, a very, very early introduction to the airplane. And I'd like to close up with, for all of you who are interested in winning a Nobel Prize, if you take on an artistic hobby, particularly performing as an actor, dancer, or musician, you have a 22 times greater chance of winning a Nobel Prize. Also writing, doing crafts work like glass blowing or woodworking, artistry, or music. It just increases your chances tremendously in winning a Nobel Prize. And in my opinion, and with some research that I have looked into, it seems to be because you have a more innovative approach at problem solving, and that separates you from the masses. So to close, I have 3 final questions to leave you all with to sort of stew over. How does systems engineering help us to generate and recognize original ideas, original concepts, and to novel our own original ideas and concepts? And what does it teach us about ourselves as a species? And what long-standing problems has it solved, particularly in relation to humanities or within the arts? And I believe that concludes my presentation. So, one last thing. These are two just very cool quotes. I'm sorry. To develop a complete mind, study the science of art, study the art of science, learn how to see and realize that everything connects to everything else. That was said by Leonardo da Vinci. And second, this is Steve Jobs more recently, 1982. If you're going to make connections which are innovative, you have to not have the same bag of experiences as everyone else does. Okay, thank you.
Thank you very much, Christine. I will give the floor to Laura, but it's been an awesome presentation. Just saying, it's so fascinating. Thank you.
Thank you. Thank you.
Christine, can I see the slide before the one that you're showing right now? The one with the three, yeah, that one. Okay, and I'll like really quickly try to translate what you said. La ingeniería y las artes parecen separadas y parecen dos disciplinas muy independientes de cada una. Pero como se han dado cuenta, nuestra presentadora en este momento viene del mundo de las artes y ha sido extremadamente exitosa en la ingeniería. ¿Por qué? Por su capacidad de pensar por fuera de la norma. Entonces, ella quiere que pensemos tres cosas. Primero, cómo la ingeniería del sistema nos ayuda a generar y reconocer ideas originales. La segunda es, ¿qué nos enseña esto sobre nosotros mismos? Y la tercera es, ¿qué problemas largos de la humanidad nos ha ayudado a resolver?
Gracias.
Thank you very much. It was so, Laura. Your skill is amazing. It's
I'm not a translator.
How you can pick up the technical things. It's awesome.
I'm not an engineer and I'm not a translator. I'm a lawyer, so I can talk a lot, but that's it.
You just blew my mind, and it totally encapsulates what I just talked about. Having a different approach, and how that can make you better at something, when it's least expected.
Yeah, thank you. I'm going to have to log off because I have a class in 4 minutes.
Yeah.
So I really wish I could have stayed for the rest of it. I'm sorry, Ian, but if you need me, you know where to find me. Okay, I'm going to go so you can continue.
Thank you very much, Laura.
Okay. You've been
great, absolutely great. Bye. George, Christine, your presentations were absolutely fantastic. And now I'm sure that Natalia has another one, which is great. We don't care about going over time. We want to listen everything about you, Natalia, now, what you have to share with us.
Thank you so much, Bianca. And hello and hola, everybody. It's been really fascinating. It's so inspiring to listen to your presentations, both you, George, and Christine. It's amazing to hear your experience. And Christine, if I can just ask you to stop sharing the slides so I can share something as well.
Yeah.
That would be great. Thanks.
Of course.
So I'll be interested in the meantime to hear from our audience of what is really your background and how much do you have to do with the aerospace engineering? It would be great if you can send us a message on the chat maybe, so we can find out. My name is Natalia and I'm the mentor at UNOSA Space for Women Network, same as Hien. And I took the approach of really trying to encourage people that would be maybe decided to go with aerospace engineering career path or are not yet decided and wanted to learn more and how to become aerospace engineer. What can you do as a career, and what challenges lie ahead? So I did prepare some slides in a minute. I think I will be able to share them, but
I see Christine is having issues logging off. Does anyone use a map?
There.
Oh yeah, there we go. Perfect.
Great, thank you so much. Great, so the slides should be up. If you can just say if you can see them.
Yeah, perfectly.
Excellent. So I'll be talking through it from my heart really as an aerospace engineer. I work at the moment as a technical project manager in the company based in the UK, in Space Missions, which is delivering small Earth observation satellites, meaning by delivering, I mean design and manufacturing. So really, why would you consider a career in aerospace? To give you a bit of encouragement, of like Christine, like George, you have in your heart the passion for aviation and passion for space, and you want to learn more and explore more technical. You want to build the spacecraft that can take humans into the orbit and beyond, and well, not only humans, exciting new projects as James Webb Telescope, the cutting edge technology. If you want to contribute to design the constructions that explore frontiers, and what is the key really is that you need to develop the logical thinking that you can do through a formal education by exploring the aerospace engineering course. Linking it to the topic of systems engineering, you can see what is the importance of really systems engineering from a satellite perspective. If you can see on the picture on the right, on the left-hand side, this is just one CubeSat that holds a lot of different components. So the system engineer here is the key person that holds the bigger picture. And he's responsible for the mission design and making sure that the customer, who usually pay a lot of money for the space mission, that the goals are satisfied and the mission is a success. So as a systems engineer is a person that will be key to take the decisions on the spacecraft. It's really complex work, and as you know already, this graph. So I think here the fact that I'm repeating that is pretty much the charm, really. It just means that it's very, very important that there is a structure in the design, and there is a methodical thinking and logical thinking of how to verify all the requirements that are on the spacecraft that will contribute to the success of the mission. So I won't dwell on that chart anymore, but I strongly encourage you to go and visit websites and learn more about each particular topic on that. So a few examples of aerospace engineers, and especially women, as I'm the mentor for the Space for Women network. Just to give some encouragement to women that are in the audience and want to become an aerospace engineer. Valentina Tereshkova was the first woman astronaut. She wasn't so much of an aerospace engineer at the beginning. She came from quite modest background, and she was really interested in parachuting. That's how she got in the first selection of the space program. But then she was really smart and resilient, and she pursued the aerospace engineering course and then the PhD, and then that led to a brilliant career. Kalpana Chala, again, the astronaut, very, very committed to aerospace engineering because she had a passion, and at the end she became astronaut. Also, recently mentioned quite often, Mary Jackson, who was a mathematician. She got really interested in aerospace engineering during her career, which led her to become a team of contributors to the moon landing, really. Everyone at NASA would know her by heart. So what really connects these women is that they were very smart, bright and committed and passionate. And this is something that you need to explore for yourself in your heart, that if you really feel that you're interested in spacecraft, space built, then just don't hesitate and learn and self-develop on how to become the aerospace engineer. If you already identify that you're really passionate about, then learn as much as you can. It can be a formal course. It could be a follow-up course. For instance, the International Space University offers a master's in space engineering. It could be just staying up to date with the current innovations and the activities all over the world, reading the reports like Bryce. So I just give you a few examples here. The next week is starting the International Astronautical Congress, the Cyberspace Edition, which is free, and you can join in and listen to the presentations from professionals. Also get involved and find a mentor. Here, I strongly encourage to join the Space for Women Network and ask for mentorship. As for me, not to brag about my experience, but more to give you some examples of what can you do. I have been passionate of space really from early years, but it was introduced by my family, by my dad. Then I joined the university. I was trying to make the most of it. So I strongly encourage you to find any associations that you could join. For instance, the global Space Generation Advisory Council, but in my university in Poland, it's not the best university for aerospace engineering, but it's offered a lot of ways of participation in projects. For instance, the aerospace design contest for drones that was held in Texas in 2013. I think that was so long time ago, but I was a part of the team, you see me probably in the picture, designing drones. We won the first place at this time. I was also part of the team designing the first CubeSat of my university, which really taught me a lot. Then I took on some leadership positions at Rolls-Royce as following up from my career in design of combustion chambers and jet engines. Then I follow up with a course in Master of Space Studies, and I am now designing managing delivery of the small satellites. So try to identify from early years what your passion is and try to make the most in staying up to date with the developments in the space industry. So thank you very much. That was the short version, and I really encourage you to join in the Space for Women Network.
Thank you very much, Natalia. Thank you again for being with us and for sharing your passion especially, and also some very key elements for any woman, because Space for Women, who want to become part of the space industry as engineers or not. We have seen, Christina, how her path was there, yours, mine as well. There are multiple ways we can contribute to space as engineers, and not necessarily starting as engineers in the very first years of our career or development or education. That said, we have time for, let's say, 3 main questions. How your background in arts has actually helped you with your engineering projects?
I think that's such a great question. I was thinking a lot about the applications for the astronauts this most recent term. And I was listening to the judges who accept the applications and review what it is that separates one astronaut from another. And some of them, I mean, they're all overachievers with these brilliant IQs who can speak Russian. And I mean, they're just all such amazing people. But I think one component that separates someone from another, particularly working on a team, specifically for problem solving like engineering, is empathy. And coming from the background of the arts and humanities, all I did for 4 years was, is observe human behavior, analyze human behavior, how humans interact with each other, and try to empathize and create characters. So I really feel that having that as my foundation has allowed me to be better as a businesswoman. It's allowed me to work better with my teams, and it's allowed me to have empathy, compassion, and patience. So I would say the primary thing that the arts gives you is empathy, which is something we so desperately need right now, particularly in the US.
Thank you, Christine. Swati, have you picked up more questions? I know that also Yara wants to ask a question.
Yes, Bianca, I did have 2 questions on my mind after looking at the presentations. Natalia, personally, I completely enjoyed your presentation because Kalpana Chala was also one of my inspirations, and her saga continues to inspire millions in my country. I also ended up at her alma mater for my master's in aerospace. My question to you would be, what do you see missing in our current engineering curriculum for next generation engineers who are ready to tackle new interplanetary mission challenges and tech concepts?
Yeah, it's a very good question. I wish I had an answer to that and we could fix it. But speaking from my experience, I think it would be great to have more experience in collaboration with teams all over the world. So between universities, for instance. So there would be more opportunities for all the students to do that, because at the moment it's just for selected groups, really. And I think we just need more practical experience, because not only studying from the books really that makes you a good engineer, is all the work that you do.
Yeah, I completely second that, especially with a lot of CubeSat competitions and projects coming up. I do believe there is a little bit of change happening, but still a long way to go.
Sure.
Yes. George, I did have a question for you as well. What are some of the human operator design constraints for crewed space flights? And also, if you could update us on any insights as to what is happening with the leak on the ISS and how is NASA handling it?
I'm sorry, can you repeat the last part?
So on 29th September, there was a leak which was noticed on one of the service modules of ISS. And how is NASA handling that situation?
Okay, as far as the leak is concerned, last I've heard is it's been kind of elusive, but you know, it's not endangering the astronauts right now. They're just having to pump more oxygen to maintain the same pressure and all that. So it's kind of eating up resources, but the leak right now is elusive at this point in time. But I'm sure and confident they're going to find it. So your question, your first part about associated, I think you mentioned human operator design constraints on crew flight operations. So one of the things that NASA takes very seriously is the safety of the crew. And so one of the documents, the overarching document for human spaceflight is what we call the human design for human spaceflight. And so this document basically calls out the aspects of safety. So, for example, preventing human error in the operations and control of the system, reducing the likelihood of human error by providing the capability for the human to detect and correct or recover from error and limit the negative effects of error. So from a standpoint of design constraints, is we have to make sure that the interfaces accommodate the human in the sense that the human, as I mentioned earlier, is not deterministic. You have perhaps one day where the human is psychologically depressed, physiologically they have a cold, they have a big headache, they can't think, and yet they have to operate these critical systems. So these critical systems have to factor that into account. And that's why we design things like inadvertent operations. So many of the critical commandings is typically two or three events that have to happen before you initiate a critical command. You know, an example is first you have to flip over a particular panel, or rather a screen of some sort to access a button. But you press that button, that's just the arm button, all right? And then you get a confirmation, command armed, and then execute. You know, are you going to execute the command? So sometimes you can inadvertently, you know, hit a button, and you don't want that to happen. So you have to have a means of preventing a inadvertent activation of a critical command. So we have to take that into consideration, and that's why human in the loop testing is very critical. And of course, human factors engineering gets involved to quite an extent. So we got three things going on in human factors engineering and systems engineering. We got the machine design, we got the human element, and we got the task design. So between the task design and the machine design, we're trying to match the machine to the task. Between the machine design and the human element, we're trying to match the machine to the human. And then the task design and the human element, we're trying to match the task to the human. So collectively we're iterating on that process to minimize the possibility of a human error. Though I have to, yeah, I was just going to conclude that you know, it's a very iterative process, and that's part of human in the loop testing as part of systems engineering.
Thank you, George. Just to add to that point, do you think there were any advances made with AI to develop this interface?
AI and human interfaces?
Mm-hmm.
Okay, so there's a few challenges associated with that, and that's pretty much associated with the collaborative design, if you will, of a human with AI. And so it's going to be a new challenge for NASA, especially going to deep space, because we are going to have a lot of artificial intelligence, you know, to basically mimic or emulate mission control, because we're going to be so far away. But the question is, how much control do we give to autonomy and automation, and how much control do we give to the astronauts? And it's going to be very much dependent on the task and how quickly are they able to recover from a system that's autonomous. And if the autonomous system is going nuts on them, how quickly can they recover from that?
Got you. Thank you, George. I don't see any other questions in the chat bot. Bianca, over to you if you had any questions.
Yara has a question.
Grazie, Bianca. Jorge, I have a question for you. So I'm going into gifted education, and we now have recent research on creativity, which is a very important skill that shows that sometimes creative individuals historically, they haven't always reached their peak at the K through 12 level. They've reached it later in life. And so I advocate for diversifying gifted education, which I feel would give opportunities for people who want to go into space industry, including with design, engineering, what have you. And I know someone personally who is from Central America, and it took them 20 years to be a citizen, and their IQ was tested very young to be 160. But obviously with it taking 20 years to be a citizen in the United States, they were like you, they had to go through a community college. They didn't have a parent that knew how to advocate for them, you know, because they came as a refugee from war. So I was wondering if you had any advice, what today could any person do to make a difference so that more people have an opportunity to get into the space industry? And, you know, parents that are new here to the country, they want their kids or themselves. You have 30-year-olds that maybe it took them a while, you know, to get resources, and they have maybe a learning curve. What advice would you have? Because it's not just K through 12 that they can get into the space industry and be competent and deliver. It's also people who are 30, 40 years old even.
Okay, so let me just take a crack at it. Yeah, I'm a product of the community college. You know, I have a very my story is not the one that I was a straight A student and all that kind of stuff. But I have to say that the community college helped me get that start as far as education is concerned. There was one community college that took a chance with me after seeing my SAT scores and said, well, we're going to give you a semester probation and you better do good, otherwise you're out. And I met the challenge. And so fast forward, I got my degrees and working at NASA. Now, for the people that are non-citizens, I do a lot of outreach to. It's starting to become international now, and so a lot of students from Bangladesh, India, Africa ask me, I want to come work for NASA. And of course, one of the challenges of working for NASA, especially if you're going to work for the government aspects of NASA, like myself, is that you got to be a U.S. citizen. But I have to share one story with a young lady from India that was in high school and reached out to me at first being a mentor and helping her with a design project, but she wants to come work for NASA at that time. And I said, well, look, it's going to be difficult. And this is pretty much what you got to do. Get your bachelor's in India and then transfer over to the United States and get in a master's program. And then start pursuing, if you can, a PhD or maybe another graduate program major that where you have a scientist or an engineer at that university, or professor rather, that's working with NASA. So fast forward about 6 years, she got accepted to Syracuse University. She got her master's in computer science. I recommended to her to pursue machine learning and artificial intelligence. Now she graduated from there. She's now at Stanford University pursuing her PhD. And she, last I heard, is that she's gonna, she is engaging a professor there that works with JPL in California. So it's been a long road for her, but she's getting there. So it takes persistence. I have to say that persistence is a key element coming to work for NASA. There's just too many stories to share here, but let me just say about one astronaut that talked about persistence to become an astronaut. His name was Mike Fossman, and it took him 21 years before he actually got accepted to become an astronaut.
Did he apply every single year for 21 years straight, or?
Yeah. Wow. He kept applying, he kept applying, kept applying. Yeah.
I have goosebumps, actually.
Well, Yara, your questions has opened up a whole Pandora box of experiences, which, you know, I would like to hear more about. Like, I don't want to go anywhere now. I just want to listen the stories. And I saw Natalia and Christine as well nodding during the stories that George was sharing. What is your take on this one? On, you know, opening up possibilities, making this engineering accessible to people that are struggling with their political, cultural backgrounds, because citizenship is something that really it's paperwork and it needs to be done. So what is your take on this?
Christine, do you want to take it first?
No, you please.
Sure, yeah. So it is really a huge problem. And I say that this is a massive blocker. The fact that some people do really have all the resources and all the skills to become brilliant aerospace engineers, but they simply come from the community or from a region of the world that doesn't have that developed market for it, such as the United States. So the United States has absolutely incredible space program. I personally come from Poland, that the space program is just developing now. So I had to really emigrate to develop my career in space. But I do hear a lot of positive stories as well of people that decided to take a turn and develop the space industry in their country, which is also absolutely plausible, to make the way for other people to discover STEAM and all the science disciplines. So more on the teacher side. What I can say is certainly that initiatives like from UNOSA, the Space for Women Network, organized by UNOSA, it's exactly serving this purpose. So it's mentors that are voluntarily helping people all over the world and how to develop their careers in space, engineering, or generally in space. It is oriented for women, but everybody is really welcome to join and just ask for advice, like George did, advice this lady from India. And now she's, as I understood, it's a success story, really, because she's pursuing the career and getting there. So I think there are blockers, but passion is really what sets the foundations really for the success. And as long as you identify that passion, I believe that with the hard work, you will overcome all the blockers, wherever life throws at you. Maybe it sounds naive, I hope not, but I believe that's the key, really.
Thank you, Natalia. Christine.
Yeah, that's so well said, Natalia, that the passion is so integral, because yeah, I know what some of these girls are up against. Just quickly, I'm dedicated to building a team of primarily women that are minorities. And I reached out to an organization called Women in Data, and quite a few of the women who have submitted for positions are from India or Bangladesh, some from Africa as well, and they don't have citizenship. But because everyone is working remote now because of COVID-19, there's a tremendous amount of tech companies that are looking for engineers that don't have, that are hungry to work, that are excited to work and problem solve, but maybe wouldn't be as expensive as hiring an engineering or software team in the US. So one suggestion I have, George was, using education and building off of that. I think that's so spot on. Another alternative is finding the resources online. There are so many courses. You can literally learn how to code for free online in multiple languages, Ruby, Python, R. You really, at this point, because of our access to free education with things like courseware and Udemy, you can learn these skills for free. If you have access to the internet, you can learn these skills for free. And from there, there are certain websites like Upwork where you can start to really build out a resume and get some experience under your belt. And then once I think you have a resume, that gives you a more fighting chance to work on maybe a smaller satellite project at NASA, and maybe as a contractor at first. And then you can build from there, develop connections. So, or work for a tech company. And there's a lot of tech companies that are now working as contractors for NASA and SpaceX because these projects are just so ginormous that they have to outsource as well. So that's another way of looking at things, another alternative.
Thank you very much, Christine. And thank you very much, everybody. I think we are generously over time. So I'll give the word back to Ian to wrap it up. Thank you.
Thank you, everyone, thank you, George, thank you, Christine, and thank you, Natalie, for this amazing presentation. Thank you all for your participation on the World Space Week. So if you have any further questions, please email us. If you wish to be connected directly with a UNOSA mentor, visit Space for Women UNOSA. Natalie, can you help me which webpage that is? You will find it on their webpage. You will see all profiles of official UNOSA mentors. There you can, as a mentor, you can then apply to be directly connected with a UNOSA mentor. They are doing amazing initiatives all over the world. They selected mentors in different areas, different countries. So it's really an opportunity for anyone, anywhere, to have access to an amazing platform and support literally for free. I mean, Natalia and me, how much did we invest for the International Space University, right? It's insane. Now everything is open. Just please don't see any obstacle. Just reach out. You're just one message away to be connected to anyone who can help you with funding, with whatever you would like to do, you know, in space and science and STEM, you know. Everyone is there to support each other. So thank you for your time. Stay safe, everyone. The last thing we do is a traditional group picture. If you decide to get on camera. George is off camera, Sonde, Alex, if you like, Martina, go on camera. If not, don't. Well, we're gonna take a shot now. 1, 2. Thank you, everyone. Stay safe, everyone.
Thank you. Thank you very much.
Pleasure.
Bye.
Nice to moderating. It's a great show.